Okay. Yeah, based upon the robotic movement, we can suppose to classify the configuration. So the main classification of the robot is up to 4, which means the main thing. So how exactly it is moving, the based upon the movement, the robot will be classified into 4 different types. Again, there is a sub classification for this fourth part. In the first part, this is called as Cartesian configuration, whereas all the joints, all the links of my robot will be moving in a linear direction, which means this arm will be moving in this direction and this arm will be moving in this direction. If there is an additional axis, then it will also move in the linear direction. So all the movement of the robot is in linear direction, then we will call it as a Cartesian configuration, or a linear robot, or a prismatic robot. So this is what exactly a linear robot is, or a Cartesian configuration, or a prismatic robot is, where all the movements will be in a linear direction. Okay. Now, well, coming into cylindrical configuration. In cylindrical configuration, what will be happened? So there will be having one rotary joint and two linear joints. So whereas what will be happening in the previous one, every motion will be in a linear direction. Here there will be having R, L, 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 which means one rotary joint and two linear joints. That is what exactly a cylindrical configuration is. This is, should be like this. So if there are three links here, link 1, link 2 and link 3. So link 1 is supposed to rotate in 360 degrees, which means it will rotate. Whereas link 2 will be moving in this direction, link 3 will be moving in this direction. These two are linear, linear, linear and rotary. Then this is called as a cylindrical configuration. Coming into next thing, that is called as a spherical robot or polar robots. Generally we will call it as spherical robots only. So here the nomenclature will be like this: R and L. So which means what will be happen, if at all I am talking about a skeleton, then this will be link 1, link 2 and link 3. So out of these three links, first link will be rotary joint, so it will be in moving in this direction, and second will be moving in this direction, upward and upward directions. So this will be rotary 1 and this will be rotary 2, and third will be linear only. So this is having R and L. So if you are talking about work volume or work envelope, then we will be having this one. This is the first one. So where the robot will work with, so we'll going to rotate with this axis, z axis, with respect to z axis. So what will be happen, you will be getting 360 degrees in this notation. And the second one is r2, so this is called as a theta 2. So which means it will rotate with respect to, if at all I'm talking this as a y, so, or if it I am talking about as x, then it will rotate according to the x. Okay, that is theta 2. And theta 3 here in this application, it is like moving in inward and outward direction, so that because of this movement I am getting this type of envelope. Okay, this is called as a spherical robot. Now while coming into articulated robot, robot is nothing but it is having all the movements in the rotary direction only. So which means the robot will be supposed to, if at all I'm talking about this type of robot, then the first rotation is theta 1, so it will rotate to 360 degrees or whatever the given condition. Second one will going to move in this direction, so that is theta 2. And third one, according to it, if at all it will going to move in this direction, it can move. So if at all it want to move in upward and downward direction, based upon the given robotic conditions, it will move. So this is the three different motions, that is called as a articulated. Let us take an example of this robot. So where what will be happen, on the base it will going to rotate 360 degrees. So this is first rotation, and there is an angle between these two. So this is called as a theta 1. If at all the theta 1 will, if this theta angle is 90 degrees. If at all I want to change it to 140 degrees, then what will be happen? So it will rotate, the robot will comes to like this position. If at all I want to reduce it to 45 degrees, then the robot arm will be like this. This is theta 2. Now I am considering about theta 3, theta 2. So here theta 2 is 90 degrees. If at all I want to change it to 45 degrees, then the arm will be like this. If at all I want to change it to 130 degrees, then it will be like this. If at all I want to change some 80 degrees, then it will be like this. So based upon this movement, it is also in rotary joint. So this is called as an articulated robot, where all the movements of the robot in rotary, revolute directions only, R, rotational only. See, the work envelope of this robot will be like this. So it can cover 360 degrees in this area, it can cover 360 degrees in this area, and it can cover 360 degrees in the upper areas also. So together I am getting this type of area. So complete a spherical volume for this articulated robot. So this is the most widely used robot in the industry, so where all the movement will be in the rotary direction only. This is called as the articulated robot. Now, yes.
सर वो जो दोनों थीटा 1 और थीटा 2 है वो तो सेम ही प्लेन में है क्या फिर, मतलब रोबोट के हिसाब से?
सी, रोबोट के हिसाब से सेम प्लेन है, बट लेकिन अकॉर्डिंग टू इट्स मूवमेंट इट इज डिफर्ड. सो दिस लीनियर जॉइंट, दिस जॉइंट is having some angle, maybe it will rotate in some direction only. So okay, I will show you a video so that you will be having clear idea on these things. Okay, so how this theta 2 and theta 1 and theta 2 will be differ, both are not same. Why? Because So one will going to move in this direction. How can I show you? Okay, fine, no problem, I'll show you a video. In that they will clearly describe you what exactly the difference between theta 1 and theta 2. Okay. Now there is a two different subclassification for this articulated. One is a Scara and second one is a called as a Puma. So these two are completely uh, additional configuration for this articulated robot, where what will be happen, some additional axis that will be involved, which will be called as a R, and one is a linear. So here there will be rotary direction. This will be also rotary direction. According to that, again there will be one more additional axis. This is used for this linear direction. This is called as a Scara appliance. And second one is a Puma robot, where all the joints will be in this rotary direction only. The additional axis also move in addition this direction. So rotary 1, rotary 2, rotary 3, even the final also rotary 4. If at all I want to place a gripper, I can place a gripper like this, and according to this it will go into move its operation. If it is having 3 4 5 axis, it can move in this according to its movement, roll, pitch, yaw, and directions. Okay. Well, coming to this one, basic motions, 6 degrees of freedom is nothing but the robot complete movement. So the robot is completely different on two different things. One is a position axis and second one is a we call it a wrist axis. Position axis as well as wrist axis, we will call it as a. In position axis, what will be happen? The robot body, which means the base, the shoulder, the elbow, all these things will going to move. So if at all it will going, it will rotate. So if at all it will move in upward downward direction, it will move in this direction. This is called as a positional axis. Whereas the wrist axis is nothing but these things. Roll, pitch, and yaw. These are the three different notations for this wrist. So based upon these six, we will be getting 6 degrees of freedom. Okay, I will be showing you a simple video so that you will be having clear idea on how exactly these movements will be classified for a robot. Okay, just a second. Yeah. Okay. Now have a look on this one.
Robots come in.
First of all, is it visible? Guys, is
Yes,
it
sir.
visible?
But
Yes, sir.
थोड़ा छोटा है screen.
Okay, fine, no problem.
Robots come in all different shapes and sizes, but are frequently classed by their degrees of freedom. Each direction of movement on the robot is considered an axis of movement. This robot rotates at the waist, bends forward and back at the shoulder, and moves vertically at the elbow. Each single movement axis is equal to 1 degree of freedom. This particular robot is equal to 6 degrees of freedom. It moves along one axis for each of the waist, shoulder, and elbow joints, and along 3 axes at the wrist using pitch, roll, and yaw. These particular motions help to locate the tool in the work area and are called position axes. Most robots have at least 3 position axes to help position the tool in the work area. If the robot were to slide along a track, it would have a 4th position axis of linear movement and another degree of freedom. While the position axes locate the tool in the work area, the orientation axes help orient the tool in relation to the workpiece. The types of movement along orientation axes are defined as pitch, roll, and yaw. These movements all occur from the same joint, the wrist, but along 3 distinct axes. This type of movement is most easily illustrated as it relates to aircraft movement. The robot's tool moves in the same way. Pitch moves the tool vertically. Roll rotates the tool about its center axis. Yaw turns the tool left and right. The position axes movement at the waist, shoulder, and elbow, along with the orientation axes movement of pitch, roll, and yaw, allow the robot to accomplish its tasks within the work envelope.
So clear what exactly it is.
Yes, sir.
Okay, so we'll call this as a positional axis as said, and we'll call as a wrist axis. Just a second, where is this cursor? So if at all I'm talking about this as a robot, then we will be calling it as a position. Okay, positional axis. So this can be called in both ways. It's a wrist as well as orientation. Anything is correct. Wrist axis or a orientation axis. So this position axis is generally used for the basic robot movement. So which means with the help of position axis only you are reaching the tool. So we are, or you are reaching the workpiece. So if there is a workpiece here, okay, from this you need to pick a path. So your robot is at this location. So coming from this location to this location will be done by the positional axis only. So which means base, wrist and axis with this thing base, okay, sorry, base, shoulder as well as elbow. So by these things only you need to do this operation. So once you have reached the tool, then by using this wrist or as well as this orientation axis, you can control the tool or you can pick the tool. Which means if the tool is in this direction, if the tool is in this direction on the conveyor, then your gripper is at this location. Then what will be happen? First of all, it need to rotate. It need to rotate to this direction so that this path will come to this face. I mean, it will going to pick like this. Then what will be happen? So it will going, gripper will going to move in this inward direction, downward direction. Then after that again it will pick in upward direction so that it will be lifting from the conveyor. Again based upon the movement I can rotate it or pitch it, I can yaw. All these things I can be doing. So this is what exactly a robot movement will be. So typically every robot will be having 6 degrees of freedom. But in the video they have shown, so if there is an additional axis, I mean if there is a linear movement or there is an additional movement, then that is called as an additional axis that not comes with this 6. This 6 motion will be comes with the robot itself. Then the additional, which means the robot need to move from one direction to another direction on the conveyor rail, or if at all it is overhanging, then there will be having some other degrees of freedom, that will be called as an additional DOF, where the additional degrees of freedom will be constraining the movement of the robot. Okay, that is called as an additional. So whereas the self degrees of freedom is nothing but the robot movement like this: base, raise, base, shoulder and elbow. These three are will be using for this one. See here, this is called as a rotation. Yes.
So it means the a robot can have more than 6 degrees of freedom.
Yes, we can have. I mean, the robot itself will be having 6 degrees of freedom, but if at all you are moving the robot, I mean, if the robot is static on the ground, then it will be having 6 degrees of freedom. So if the robot is not static, I mean, it is not fixed on the base, I mean, the ground, then it should be having additional also, additional degrees of freedom. If at all it is moving, then it will be having 1 degree, additional 1 degree of freedom. If it is rotating at the same time, not only moving, then it will be having second degrees of freedom. So now what will be happening? See, these additional two will be coming into existence. This is called as an 8 degrees of freedom robot. So what will be happen? 6 degrees for the robot as well as 2 degrees for the movement of the robot from one area to another area. Generally, these type of 8 degrees of freedom, 10 degrees of freedom, these type of robots will be used for in the spray painting application, where what will be happen? The automobile body comes into a place and it will be sitting here. I mean, it will be fixed at a location. So the robot which is fixed in this location, not only fixed, it will be given some rail here so that it will do the operation at the same time. Simultaneously it will move and it will do the operation. So if it is defined in the upward and downward direction also, then it will be called some other thing. So based upon the movement of the robot, this also additional axis will also be considered. Okay. Okay, this is up to this session. Now we will be entering into next session. Okay, before entering into that, I will ask you, I'm going to ask you these things. Have we discussed this thing? Definition of robot,
Yes, sir.
Yes, sir.
uses,
Yes, sir.
Yes, sir.
basic robot movements,
Yes,
Yes,
sir.
sir.
where and why we are going to use robotics.
Yes,
Yes,
sir.
sir.
These things will be going in the next session. Application, advantages, disadvantages. In a brief, I will be discussing in the last phase. Okay, now I will go into next one. Here we are going to discuss about the robotic simulation, how we are going to do this. If at all I want to go for a robotic, I mean in-depth knowledge, then these are the things I need to go for it. First one is this is the thing I have already described you in the previous video. I mean in the plant simulation itself. So see how the robot will be placed in this location, on the top location, how the robot will be placed on this location. So if it is a spray painting application, how it is performed. If it is a base, how it is performed. All those things. Okay. Now I will be showing you this again. While coming into configuration, I mean classification, like I already told you with a, with a block diagram like this. So here exactly this is called as a block diagrams of this robot configuration. First one is a Cartesian configuration or a linear configuration or a prismatic configuration where all the movements in the linear direction. See here the block diagram, this is 1 and this is 2 and this is 3. So all the movements are in linear direction. Here it is a cylindrical where what will be happen, the first link will be in the rotary direction and the second and third will be in the linear direction or a prismatic direction. And the third one is a RRP. Their first joint is a revolute joint, second joint is also a revolute joint, whereas the third joint is a linear joint. While coming into fourth, so this is articulated robot where what will be happen, this is also revolutionary, this is also rotation, this is also a rotational joint. Three different rotational joints will be considered as a RRR. So if at all I'm talking about a SCARA, then this is the first and this is the second, this is the third as well as this is the fourth. So based upon this, we will be using this RRP or RRRP. So that is called as a SCARA robots. Okay, now we'll be talking about one important thing. This is called as a joint configuration, where what will be happen. See, all the links. This is a link one and this is link two. Like I said you in the yesterday session. So how these two links will be connected? So there is one link and there is second link. How these two will be connected? So if it is a linear joint, what type of joint I need? I mean, if there is a linear movement, what type of joint I need to use? If there is a rod, this one B, rotational joint, rotational movement, then what type of joint I need to prefer? Okay, if it is a linear joint, then I need to go for some rack and pinion assembly, where what will be happen, a lead screw will be there here on this one and there will be a screw here. So when the power comes to this one, automatically this is a fixed one. So automatically this robot, this arm will be, this lead screw will going to move from this direction, from this direction. This is called as a linear joint. If one hold, I mean at this corner it need to hold and it need to revolute. Then what will be happen, directly a motor shaft is connected to this one and a gear will be connected here, so that the motor will going to lift this part. This is called as a rotational joint. And one more thing is there, that is called as a twisting joint. Any idea on this one? Twisting joint? Have you heard this word? Couplings.
Sir, joints which are made through, for example, bearings or
Yes.
means.
Yes, correct. See, if there is a coming from this direction and I want to give the same direction only, and there is the length of the shaft is fixed. I mean, the length of the shaft is only some 10 centimeters, and we can't increase that length. Now, how can I supposed to transfer this from to this next shaft? Then I need to use by using some sort of couplings or a bearings or some sort of devices, old ham coupling, universal coupling. With this, what will be happen? This motion will be given to this motion. Okay, there will be having two things that will be fixed here and this will be given to this one. This is called as a twisting joints, where we are using some sort of couplings. And the second one is a revoluting joints. So revoluting joint is nothing but, I hope you know differential or bevel gears. Then what will be happen, the motion is coming from this direction and it will be transmitting to this direction. If at all I want to change the direction, then I need to use some bevel gears here like this. So because of the bevel gear, what will be happen, this motion will be converted to this motion. This type of joint is called as a revolving joints. Okay, these are the some of the joints that will be given in this in the robotics. Okay, and this revolute joint will be having 1 degrees of freedom. Why? Because Let me give you a simple example. Okay. Let us consider this thing. Okay, only this part. This base was fixed to this. This is a fixed support, and there is having a connection. In that connection, this link will be connected. Okay, only this link. Now, how many type of movements can this going to happen? This one. What are the different movements that one can perform?
Motion in XY plane
Okay.
if Y is upward and X is horizontal.
Okay. Now it is a holded by screw and bolt assembly. Now these two joints will be holded like this. So now is it possible to move in X direction? Linear. Is it possible to move in linear
No, sir.
direction?
No, sir.
No,
Is
sir.
it possible to move in Y direction? Upward and downward?
No,
Yes,
sir.
sir.
Yes or no?
No, sir. No, sir.
No, linear
No,
direction
sir.
is impossible. Why? Because one end of that component is fixed to this location, fixed at X position. So now there is no linear joints, no linear will be fixed. Why? Because one end is fixed. So it can't be moving in X direction, it can't move in Y direction. At the same time, it can't move in Z direction also. So all the linears will be constrained. Now, we're talking about angles. Now, is it possible to move in this direction, theta 1? If at all I'm talking about this theta 1, is it possible to move in theta 1?
Yes.
Yes, sir.
Is it possible to move in theta 2? See, this one.
Yes, sir.
Yes, sir.
No,
Yes, sir.
Yes or no?
Yes, sir.
Side direction. See, upward direction
Yes.
theta 1. Side direction.
No, sir.
See, in the top view, it will be like this. There is a joint and there is this one and it was holded like this. And there is a screw. It was bolted here. It was bolted here in top view. Now, is it possible to move in this direction?
No, sir.
No, it is not possible. So theta 2 is also not possible. Why? Because it was fixed like this. It is capable of performing only this operation, but not this operation. Simultaneously, the twisting also. Is it possible to twist? I mean, is it possible to rotate itself like this? If at all I'm
No,
talking
sir.
this one, is it possible to rotate like this, like a clockwise direction or anti-clockwise direction? It is not possible
No.
here also. So there is only one moment if it is a joint like this. So this joint is having only 1 degrees of freedom. Okay. Similarly with the prismatic joint also, linear joint. See the linear joint, it was like this. So there is an hub here. In that hub, this lead screw will be fixed. Now is it possible to move in Y direction? So if at all I'm talking this as a Y, is it possible to move upward and downward?
No, sir.
Is
No,
it
sir.
possible to move in X direction? This is X.
Yes, sir.
X is possible. Now
Yes,
what
sir.
about Z?
No, sir.
Z
Not
is
possible.
also not possible. Now we will be talking about angle, rotational axis. Is it possible to twist? This is theta 1. Is it possible to twist?
No, sir.
Okay. Is it
No, sir.
possible to rotate an angle on X direction?
No, sir.
Is it possible to rotate in this direction?
No, sir.
This is called as a prismatic. So based upon the joints, the degrees of freedom will also be considered. Whereas we are talking about, if at all we are talking about spherical joints. See here. This is a spherical joint, just like our ball bearing. Now what will be happen? Now will there be any X moment?
No, sir.
Will there be any linear movements? The linear movements will be zero. Why? Because the
Yes.
hub is fixed one. So the linear will be zero. Now what about the rotational? Will it possible to move X, Y and Z? I mean alpha, beta and gamma. Is it possible to move in alpha, beta and gamma?
Yes, sir.
Yes, it is
Yes,
possible.
sir.
Why? Because so there is a
Yes,
ball
sir.
here, and inside the ball there is one more ball here, and it will be supposed. So now it can supposed to rotate. It can supposed to rotate like this. It can supposed to rotate in three rotational axis. So it can rotate. Whereas the linear motions is constrained. That is why a spherical joint will be having 3 degrees of freedom. So based upon the joint, based upon the moment also, these joints will be considered. Okay. Now one of the important topic, robot motions, which means till now we have discussed about robot movement like linear movement, rotation movement, all these movements. The robot need to pick a material from this and it need to place to this location. But how this was happened? So how this motion was happened based upon these two only. Okay. Let me erase all these things. The main robotic motion, the main robot control, I mean the movement will be depend upon these two only. It's maybe point to point and it's a continuous path. So these two are generally used for the movement of the robot from one direction to another direction. Okay, now before entering into it, I want to ask you something now. I hope you know graphs, right? 0 0. Okay, 1 2 3 4 5 6 6 5 4 3 2 1 1 2 3 4 5 6 7 8 9 9 8 7 6 5 4 3 2 1. Same 1 2 3 4 5 6 7 8 9 10 11 11 10 9 8 7 6 5 4 3 2 1 1 2 3 4 5 6 7 8 9 and 10. Now I want to plot a point. See here, this is case A and this is case B. Both are different. First we will be talking about case A. This is for A and this is for B. There is a point here. Okay, this is called as a A, Z point. Now what are the value of Z? Z1.
1,3.
Okay, 1 comma 3. Now Z2.
2,6.
Z2 2 comma 6. Z3.
5,5.
Okay, 5 comma 5. And one last point. This one Z4.
4,8.
4,8.
4 comma 8. Now see, same points I am going to plot here. First is 1 comma 3. 1 and 3. This is Y1. Now what are the values of Y? Okay, now before telling it, this is a, on what basis you have plotted these points? So how you said this is a 1 comma 3? How the Z1 will be 1 comma 3? On what basis you have said this one?
So, so because from origin in X direction it has 1 unit and in Y direction it has 3 units.
Okay, which coordinate system you have considered here?
So linear.
Cartesian.
Absolute coordinate system, ACS. ICS, which is nothing but incremental coordinate system. Have you heard these two? Guys,
No, sir.
okay, fine. I will explain you. Till now, what have you learned? What have you drawn on the graphs? All those things will be considered this ACS only, absolute coordinate system, which means for every point, what will be the base point? Origin, which is nothing but 0 comma 0. So if you are talking about Z3, then you will be, you said that there will be 5 comma 5. On what basis you said that? Why? Because from 0 it will be having 5 units from this, and from 0 there will be having 5 units on this one. Then you said that 5 comma 5. If it is a second point, then you said that 2 comma 6, same basis, 2 from 0 0, and I mean 2 from x and 6 from y. So based upon that you said 2 comma 6. Now this is called as absolute coordinate system, where all the points will be considering 0 comma 0 as reference. Okay, I mean the previous point. Now in the incremental coordinate system, what will be happened? See, now first point is, what is that? This is y1. What is the first y1 coordinations here? 1 comma 3. Same. Why? Because the reference is 0 comma 0. First point is y and second point is this one, y comma 3. Now what are the values of 2 comma 6 here? What is the second point? 2 comma 6, which means 2 from this one and 6 from this one. So if I have plotted the same point here, then y2. In y2 what will be happened? The configuration will be y2 is also 1 comma 3 in my incremental coordinate system.
So it means we have to consider a second point with reference to the first one.
Yes. In incremental coordinate system, what will be happen? In absolute system, for every point, the origin will be as a reference point. Whereas in incremental coordinate system, the previous point, okay, the previous point will be considered as reference for every point. Now, what is the third point here? Third point is, we have noted 5 comma 5. So,
So 4, 2.
yes, wait. So this is the point. So this is y3. For y3, what will be the y3 value here? Try to consider. So this will be your previous point. So by considering this, what is the distance between these two? X units. How many units? Here there is a 2 and here there is a 5. How many units?
3.
So 3
3.
comma y. How many units?
-1.
-1.
Yes. That's it. Now fourth point is 8 comma 4. 4. Okay, this is y4. Now what will be the value of y4?
1,3.
-1, 3.
Yes. See here it
So
is moving in this
-1, 3.
direction. So minus 1 comma, how many units in the top? 3.
3.
Clear?
Yes, sir.
Till now we have followed for any type of measurement or for any type of graph, we will be considering this as a base, absolute coordinate system as a base. Why? Because this is a default one. So when coming into programming, or if at all you want to learn some what is this, part programming for CNC machine, or if at all you want to learn some robotic programming, then definitely these two comes into place: absolute coordinate system and incremental coordinate system. Even in the part programming for CNC machine, you need to write as Z90 or a Z91. It's absolute coordinate system, which is an incremental coordinate system. So you need to define on which basis you are completing this process, that you need to define in the initial phases. Similarly in the robot also, on which basis you are running with. So you want to adopt a absolute coordinate system, or you want to adopt some incremental coordinate system, that you need to adopt in this robotic motion also, in this robot also. Okay, now what is the advantage of these two? What is the advantage of absolute? What is the advantage of ICS? Or what is the necessity of ICS? This much of complex parts is there. Okay, now what is the necessity of this much of complexity? Okay, I will explain you
Sir,
that. Yes.
sir, ICS can be used for a means path. Means suppose a product is going on path,
Hmm.
and we are means locating it. So we will have to look it with the reference of the previous where it was previously.
Yes. See, if the number of points is more, here there is a 4 points, so it is easier. If there will be having some 50 points, then what will be happen? Every point it will be considered as a zero. And sometimes what will be happen? The path, I mean, there is a plate here. Okay, in that plate, this will be my 0 comma 0, and this plate is having some 500 x units, which means 500 centimeters. For every centimeter there is a plot. Here they will be having 250 centimeters. For every centimeter there will be having one point. Now it is easier up to this. Why? Because there is a reference here. So what will be happen if I reach at this position? If I reach at this position, here there is a 240th part at this position, which is some 240 comma 6. 240 comma 6. This is 49th point, and there is a 50th point, that is nothing but it is like a 180 comma some 118. Now how can I supposed to plot this type of point 180 comma 118? Now again what will happen? I need to go to this location. I need to consider where exactly is 118 is there, and in that I need to go to this location, and there is somewhere long side, so I need to consider this one. So at some maximum number of points, what will be happen? This absolute coordinate system will be having some difficulties. Then what will be happen if it is an incremental coordinate system? If incremental coordinate system is there, the previous point is 240 comma 5. It can't be 240 comma 5. So the previous point is at this location. From this point it will be like a 10 comma 4. Then it is easier. Now after 10 comma 4, this is this point. Okay, this point is 10 comma 4 from the previous point. Now after this point I have given some minus 20 comma 6. Now it is easier for me from this unit to get back to the minus 20 units and 4 units. So this is where we are going to use. If there is a number of points, if there is a continuous movement will be there, or if at all I want to track it each and every point, at that point what will be happen? This incremental will be considered. But some cases they will be considering this also based upon the user interface, based upon the user possibility. I mean, if the user completely want the programming to be in absolute coordinate system, then he can do this absolute also. If the user wants to do the programming on ICS, both will be available based upon the complexity, based upon his usage. So we can use any type of programming, either it may be absolute or it may be incremental. We can pick on both. So but the machine is capable of doing both. Okay, this is the main advantage of this ICS. Okay, clear so far with these two things?
Excuse me, sir.
Yes.
Sir, anyhow, for locating, we should be knowing the absolute coordinate system, because means for means ICS,
Hmm.
we have to subtract the ACS from the means particular coordinate. No?
Hmm. Yes, the same
Then
one
it will
only
be
here. But what will be happening in a machining movements? Okay, while doing the machining part or while doing the spot welding application, it is easier for them to pick a previous point, consider as a previous point. But this ICS also follow the absolute only, the principle of absolute only. That will be considered as the principle. See, if y comma 3 is there, here from this point I am giving minus 4 comma 4. Now how it will be considered? This point will be considered as a 0 comma 0, and from the 0 comma 0 they will be considered as a minus 4 units here, and they will be considered 4 units here. The principle is same, but here what happened in this ICS is they are not considering this origin itself 0 comma 0 as a standard reference, but they will considering this point as a reference. Again, that reference they will be using 0 comma 0 only. So this will be 0 comma 0, and they will be following the same absolute coordinate system rule only. This will be 0 comma 0, and from this point the next point will be 0 comma 0. So for every point, that is called absolute 0 ABS ACS. See, here this will be ACS, here there will be ACS, here there will be ACS. Every point here there will be ACS, here there will be ACS. Every point it will be considered as a absolute coordinate system, and it will be collecting the readings from this one. The principle is not
okay,
changing, the
sir.
principle of ACS is same. What?
Yes, sir, got it.
Yes, here it will be considered as a master, here it will be an individual one. That is the difference. Okay, now I hope you are thorough with these two things. Okay, if you are thorough, then we will be entering into these two main phases. Clear? Okay, now I will be explaining you two different things, point to point and continuous. See, in point to point, what will be happened? The point to point robot is capable of moving from one point to another point. The locations are recorded in control memory. Point to point do not control the path of to get from the one point to the next point. See here, the main advantage of this point to point is, I will explain you point to point. This is a path, I mean this is a plate where I am good, where I want to do some sort of application here. In this application, I want to, this is my home position is at this location. Okay, now I want to go to some other, first point. Okay, after that I need to reach second point, after that I need to reach third point, after that I need to fourth point. Again here there will be fifth point, sixth, 7, 8, 9, 10, 11, 12. 12 different points, 1, 12, 10, 8, 6, 4, 3. Okay, now we will be having these many number of points. Now in point to point what will be happened? The robot initial position is this one, home. That is nothing but a work, I mean initial home is at this position, but we will call this as a work coordinate system, or WCS, or we have defined this as an artificial home. So the robot will come to this location and wait for the operation to run, or wait for the cycle to start. Once the cycle is started, the program is, first the robot need to come to this location. Okay, then there is a spot that need to be welded. Okay, there is a spot that need to be performed. Once the spot was done, okay, again it will be coming, moving to this location, again it is doing its spot, again it is coming to this location, again doing its application. Like it will be completing up to 12, it will be reaching the 12th location. Once it was done, then again it will be coming to this location. This is what exactly happened here. Now what will be happen for this movement? The movement between the parts will be given as some 5 kmph speed. 5 kmph speed. Now what will be happened? First point, a spot welded was done. Then again it will start picking the velocity. Once it was about to reach this location, it will be reducing its speed to 0. The robot need to be completely static for doing the spot welding. It need to be fixed at a location. Okay, again a spot was done. Now the spot was done, again the robot will picking a speed and it will be reaching to some direction, I mean the 5 kmph speed, and it will be reducing when coming to this point, and it will be 0, coming to 0 position, and the spot was performed. And it will be doing the same thing, and it will be considering the 0 0, and it will be coming to 0 location, again the spot. So similarly the robot need to do the same application. Even after here also it will be coming with a 5 kmph speed, and it will be reduced, and it will be static at this location. The velocity will be 0. The robot need not to move any direction, I mean it will be completely 0 velocity. Then the spot will be performed. Once the spot was done, again it will be picking the velocity, and it will be reaching to its home position, H1 position. This is here. So this is what exactly happen in this point to point, which means controlled manner. In controlled manner, the robot will come to one position, and it will be reaching to second position. Again, it will be stopping. Again, from the second, it will be reaching to third position. It will be stopping. Again, from this position, it will be reaching to some other operation. It will be stopping. This is what exactly point to point is. Clear? See, the point to point robot is capable of moving one point to another point. The locations are recorded in the control memory. So every location will be recorded in the storage which was defined in the control storage. And P2P does not control the path to get from one point to another point. Okay. Now what happened here? See, there is a 90 degrees. There is 90 degrees here, and the robot will follow the 90 degrees anyhow here in point to point. If there is a point here and there is a curvature here, for every point the robot need to follow the curvature, then definitely the robot will follow this curvature in point to point. Why? Because we have given the points at each and every location. That is called as a point to point. Okay, this point to point will be having lot of applications like spot welding application, where the robot need to be fixed at one particular location, the spot application need to be performed. At the same time, hole drilling. So there is a drill, I mean this is a robotic arm, and at the end of this one there is a drill that is attached here. Okay, so now the robot will come to this location, and it will be at a 0 0, I mean 0 velocity. Now the drill operation will be performed. Once the drill was done, again the robot is picking with some speed, 5 kmph speed, and it will be reaching to this location, and again a drilling operation need to be performed. Once again it was done, again it will be coming back to its original location, and the same will be performed till 12th. So it will come to this location, and the velocity will be 0, and the robot application will be performed, and then once it was done, again it will coming back to its original position. That is a hole drilling application. Mission loading and unloading, which means there is a conveyor here. From the conveyor, the robot need to pick a part, and it need to place on a mission. So the robot will pick a part, and it will come to its location, I mean the mission location, and the velocity will be 0. Once it was 0, then the part will be released. So the vice or the jigs and fixes on the mission will be holding that part, When once the part was released, again it will be coming back to its original location, I mean previous location. That is machine loading and unloading. Even assembly operations also. Assembly operation, what will be happen? Parts from different conveyors will pick, and it will be reaching to a location, and once it need to place on this convey, I mean on this assembly table, then here with some velocity it will pick a part, and it with some velocity it will reach here, and at zero velocity, which means the robot need to be completed zero location, and the part will be released here. This is assembly operation. These are all simple application, I mean point to point applications, where the robot need to follow the point to point method, which means for every point the robot need to comes to zero position, zero velocity, zero speed, and again it need to maintain the speed. Again it will be reducing, again it will be increasing, again it will be decreasing in point to point. This is what exactly happen in the point to point. The main advantage of point to point is it will record each and every data, and it will follow the given line. So if at all I want to follow this type of line, then automatically the robot will follow. Why? Because we have given the instructions to follow the path, so it will be following. Here for this one, so it's upon the operator. So if at all our operator want to go for ACS, then he will be giving points based upon this one, which means first point will be some 2 comma 2, second point will be like a some 10 comma 2, third point, sorry, 10 comma 2, third point will be like 20 comma 2, or or 40 comma 2, 50 comma 2, 60 comma 2, again here 60 comma 4, 60 comma 4. So like if it is ACS, then he will be following the absolute coordinate system. If at all you want to follow ICS, then he will be giving the same thing. So here it is a 2 comma 2, and here they will be giving 10 comma 0, and the same point will also be 10 comma 0, 10 comma 0, 10 comma 0, 10 comma 0, 10 comma 0. Here he is giving the value 0 comma 10, and here from this point he will be giving 0 comma 10, here they will be giving 0 comma 10. From this point he is giving this point as a minus 40 comma 0. So it's like this. So based upon the user interface, based upon the operator interest, so he can pick ACS or absolute in the point to point conditions. Clear with the point to point?
Yes.
Yes, sir.
If it is a limited
Yes.
application, or if the application that will be needing the robot at a static condition, which means the robot need not move in a, see what will happen if the robot will continuously move in the drilling application. Let us take an example of this one. There is a drill that is performing here, okay, so the robot is coming to zero position, and the drill was happened. Now what I need to do in a okay, I will explain you in the continuous one. Continuous path. In continuous path, the robot is capable of performing movements along the controlled path. All the points along with the path must be stored explicitly in the robot control memory. Straight line motion is the simplest example of this type of robot. Some continuous path control robots are capable of follow smooth curve path that is being defined by the programmer. In such cases, the programmer manually moves the robot arm through the desired path, and controller unit stores the large number of individual points along with the path in the memory. In controlled path, what will be happen? Okay, the same application is there here. First point, second, 3, 4, 5, and here you want to follow this path, and he hasn't given any values, and here you want to follow this path, and here he has given in here, and this point, here this point, and this point. Now in continuous path, what will be happen? The robot is having 5 kmph speed I have given, so it will try to maintain that speed at each and every point. That is what exactly continuous path is defined. So it won't stop at any position, it won't stop at zero, and I mean the robot is don't come to this zero position at anywhere. So if we have given 5 kmph and a path, then the robot will continuously complete the path with 5 kmph only. So if you have given some, at this position we have given some program for 4 kmph, then while coming to this position the robot will maintain this 4 kmph, and it will move with a 4 kmph only. So this, in this continuous path, the robot won't stop at any point, just like the point. But point to point, what will be happening at every point? The robot will come to that position, and the robot will be, paused. I mean, the speed of the velocity of the robot will be coming to zero. But in this continuous path, there will be no any zero position. So if we are given 5, then it will be continuously doing the 5. Here, what will be happen? The program will be start at this position, and with this, the robot will 1, 2, 3. Just a second. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. Now, if I move the robot with a controlled path, continuous path, what will be happen? The robot will start at this position and it will continuously move like this. And at this location, it won't even follow this 90 degrees angle here. It will follow a smoother curve, resultant curve for this reaching this position. And again, it will be reaching to this position. After 10th, it will be following a smoother curve and it will be reaching to this location. So this is what will happen in the continuous path. In the initial run, the programmer or the operator need to give this line. So how much curve he want curve like this or he want curve like this. So he have to define this curve, then automatically the robot will follow the same thing continuously. In this continuous path, each and every data, even this data, see there is no any point in this curve, but still the robot will collect this data and control the, I mean, it will save this data and it will follow for the next runs. If at all the robot need to run for 1000 number of repetitions, it will run on the same basis. It won't even, there is no need of given the points also. But initially we have to define what type of curve we need to follow, whether I want to follow clockwise curve or whether I need to follow this anti-clockwise curve, I need to define. So based upon the curve that is defined, so automatically the robot will follow this one. And at no any point the robot will follow this 90 degrees. Robot will always try to maintain some curvature, always try to follow some least resultant area, so that it will reach the given path in the given time. So it won't follow this one. If at all you want to follow this 90 degrees, then you have to define a point here, then only the robot will come to this location, it will move. Otherwise the robot will definitely follow this type of things. These are the different things that will be followed in this continuous path. Okay. Some of the examples for this continuous path is spray painting, finishing, gluing, arc welding application. See here, we can't produce, like already told you, if it is a drilling application, this is a path. Now, in this continuous path, what will be happen? The robot will continuously moving like this without even reducing its speed. Now, I want to do an operation, drilling operation here. Now, what will be happen? The robot will always maintain the speed and it won't change its speed. So here, if at all I want to do some drilling application, then again I need to give some zero condition. For getting zero condition, what will be happen? It won't come to like this. I mean, the robot will come to zero position and it can't come to zero here. The robot will try to maintain the speed, try to reduce the speed from this point, and it will reach this point as a zero and continuous. So that what will be happen in side view, if it is a side view, there is a tool here. The tool will comes to this location. This is A point and this is B point, continuous. So now the tool will to come to this location. After that the tool will come to this point. I mean, the tool comes to downward direction and need to reach this direction, and here there is a drill that need to be performed here. Okay. So here the speed is some 5 kmph, here the speed is 0 kmph. If at all I have given the same path in continuous, then what will be happen? The robot will try to come to this location with reduced speed. So directly at this point, what will be happen? The tool is still moving and everything is happen here, a working condition only. So there is a damage, there is a collision that is going to happen here. That is why, so we are not going to use this type of path where the tool as well as the workpiece will going to meet at a simple location. That is why point to point will be preferable for the specific applications, like if it is a I mean drilling application, spot welding application. At this application, what will be happen? The movement need to be constrained. It need to, the robot need to come to this location and the robot need to completely hold, then the tool movement will be happen. This is what will happen in continuous path. Whereas in continuous path, what will be happen? There is a continuous movement will there. If the tool need to come to downward direction, it will come in a control, I mean continuous manner. So you can't say like this, you need to come to this location and after that you need to go to this location. It is not possible in this continuous process. Like I already told you, so this 90 degrees is not possible in continuous. So if at all you want to give, you need to define this point and you need to control this point. Whereas this is a, again, if at all you want to define like this, then what is the need of this continuous path? Then definitely you need to go for the point to point. So this is what are the main advantage. If it is a continuous application needed, then the best example is spray painting. Spray painting, what will be happen? A part is there, an automobile body is coming here. The robot will always continuously do the application without even stopping. So it will be doing with continuously. Once it was done, even the it will be spraying the paint and it will be holding at this position. This is a home position. This is what will happen in the spray, as well as finishing, gluing, some of the arc welding application. On arc welding application, what will be happen? There are two paths. Okay, this is part 1 and there is plate. Okay, plate 1 and plate 2. Now there need to be a continuous weld, that weld need to be happened. Now in this application, just assume if it is a continuous, here I need to start my application and I need to stop my application is here S2 S1. At S1 I have given robot to follow this line. At the same time I have given some speed 5 kmph and everything, so that what will be happen, it's a continuous, so the robot will do the continuous application like this, and it will going to stop at this instant only once the part was done. Now the same application, what will be happened if I use a point to point? Can you tell me what will be happen if I use a point to point S1 S2? How many points I need to define? If the length of this part is some 50 centimeters, okay. Now I want to do an welding application. This is a continuous path, and here I am going to use point to point path. Now with the help of point to point, how can I supposed to define this welding application with point to point?
It will be very difficult, sir, because we have to define infinite number of
Yes,
points.
we have to define infinite. See, even though if I assume for every 5 centimeters I have defined a part 1, 2, 3, 4, 5, 6. Like for every 5 millimeters I have defined a point. Assume. Now what will happen? At the first point, the robot will do application. At the second point, for the second coming application, what will be happen? The robot will again come to, I mean, peak to its upward direction. Again, it will be reaching to second, I mean, next height. And again, the tool will be coming to the downward direction. Here, the tool will be coming upward, and the movement will be happen for the next 5 mm. Again, the tool will be coming to downward direction, and again, weld is going to happen here. Again, what will be happen here after welding was done? Again it need to be stopped, and again it need to maintain a speed. Again it will be coming to back location. In the meantime, what will be happen here? What will be happen at this particular point?
So a gap will be left.
A gap will be there. At the same, sometimes what will be happen, material cloggage will be happen. Excess material will also be dispatched here. Excess material will also be loaded here. That is again a bigger problem for a welding area. Okay, so based upon the application we have to define this one. So for welding
Plus
type
it
of,
will take more time also.
yes. For this type of applications, if it is a I mean, based upon the application only, we have to define which path I need to follow. So whether I need to follow point to point, whether I need to arc welding. Let us take an example. If it is spot welding application, now I want to do a spot on this basis. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now what will be happen if I use a continuous? I hope you have seen the spot welding, right? In spot welding, there will be having a calipers like this, okay, to the robot. This is a static, I mean it is a fixed one, this jaw, whereas this jaw is movable one. There is a tool that will be moving inward and upward direction, and once the part will be coming, two plates will be coming. Once it was in zero condition, then it will be touching this point. Now what will be happen, anyhow this will be touching the first external surface, first plate, and the second, the tool will going to touch this part. Automatically a spark will be generated, that is called as a spark welding, where the spot welding will be happened. Now once it was done, again the tool will be coming back to its original location. Again it will be reaching, if the second point will be at this point, then it will be reaching to this location. Again this, the upper jaw will touching this point. Once the upper jaw was fixed, I mean once the upper jaw was touched the plate one, then the lower jaw, I mean the tool will going to move from this direction to upward direction, and it will touch this one. So based upon the positive and negative touch, there will, what will be happen, a spark will be produced, a spot will be produced. This is the second spark, they can spot. Again the operation was done, automatically the tool will be coming back to its original location, which means there is a gap between these two. Again, so the robot will move slightly upward direction, so that this upper jaw is not touching this part, and again it will be moving to the third part. Once the third point will be reached, again so the robot will be coming to downward direction, maybe 1 mm or 2 mm, so that the upper jaw will touch this part. Once the upper jaw will be touching here, then this is fixed, the robot will be moving, the movement of robot is zero. Now the lower jaw, I mean the tool from this position will be coming up to down upward direction. Again a spot will be happened in the third point. So this is what will happen in a point to point manner, or in a spot welding application. Now if at all I want to do the same application by using continuous, now what will be happen?
It will weld whole path and excess of material will be lost.
Yes. In spot welding, there won't be any continuous weld. Instantly the tool will be damaged. Why? Because instantly here the welding is also same application. So there is a positive electricity, negative electricity from here, and there is a positive electricity from here. So that what will be happen? A spark will be generated. Because of this, the material will be welded and a spot will be happened here. If at all I'm trying to drag this continuously, what will be happen? Because of the drag, the tool instantly the tool will be having high temperature at this point. So if the temperature, if the petrol I want to do this one, then automatically the tool will be damaged, material will be damaged, everything will be damaged, even the setup. I mean, there will be having errors continuously, and there will be a material removal or success of material removal. Instead of a spot welding, there will be a possibility of material removal. There will be a continuous hole will be happened like this instead of welding. This is what will happen if I use a continuous welding in this application. That is why. So based upon the application, so we have to define which type of path I need to prefer. So whether I am going to use a continuous path, whether I am going to use a point to point. So based upon the application. Clear with this one? Same here also. So if at all you want to follow this welding application, this is a 50 centimeters of length. Now, based upon the user interest, so whether you want to follow the ACS or ICS, up to his interest. So if at all you want to follow ACS, then if it is a starting point 0 comma 0, then he will define that up to 50 comma 50, 0 comma 50, you need to define it. So automatically what will be happen, this will be defined based upon his interest, based upon this application, whether spray painting, gluing, based upon the application you want to define. So whether you want to follow ACS or ICS, it's up to his extent. Okay, clear with these two things, movements, point to point as well as
Yes.
control.
Yes, sir.
All the CNC missions at the same time, robots will follow the same thing. Even in the CNC mission also, we are following the same. Just a second. There is a turning machine is there. I want to do. I want to do this type of turning for a cylindrical shaft. Okay. Now how can I suppose to define this is as axis? If it is a absolute coordinate system, then what will be happen? I will be considering this as a 0 comma 0. Okay. I mean x0 and z. X comma z values will be there here 0 comma 0. So if at all I want to move in this direction, then automatically this unit will be 1 centimeter, 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 1 centimeter in this direction. Even this length also 1 centimeter, 1, 1. This is also 1, this is also 1. Now, what is the total height of this one? What is the diameter of this one? This is also 1. What is the diameter of this shaft then? See, this first,
6.
yes, 6. This is 1 and this is 2 and this is 3. So the diameter will be dia 6. So now I need to consider points. First point will be 0 comma 0 as this one. After that, what is the first point? See, this is 1 or A, this is B, C, D, E, F, G, H, I, J, K, L, M, N, O, P. These many points. Now, what is the value of A?
1 comma 1.
1 comma, see, this is the point. 1 comma 1, 1 comma, sorry, 0 comma 1. Why? Because the point, the center is nothing but axis. So here it is going in this direction. So 0 comma 1 on that line, why 1 is moving one direction. After that, B, what is the B value?
So 1 comma 1.
Yes, no, X, negative X, Y, negative Y, or Z. Based upon this one, we can choose. See, now the movement is moving inside. So which means B is nothing but minus 1 comma 1. Sorry, minus 1 comma 0. Clear? See, B is moving in negative direction. So 0. Now what will be happen to C? Guys, is it clear first of all? Is it visible? Hello?
Yes, sir, it's visible.
Okay, fine. Now what is the value of C? Okay, this is the shaft. This is my 0, O comma, I mean origin, and this point is A, B, C, D, E, F, G, H, I, J, K, L, M. Okay, now see, this is a positive. If at all the tool is moving in this direction, then it is a positive value. If the tool is moving in this direction, then it is called as a negative x value. Same, if the tool is moving in this direction, then it is a y plus y or z. If it is moving in this direction, then we will call it as a negative y or z. Now what is the value of 0 comma origin is 0 comma 0. Origin is nothing but 0 comma 0. Now what will be the value of A?
So 0, 1.
Okay, 0 comma 1. Now what will be B?
So minus 1, 1.
Minus 1 comma
1.
yes 1. C?
So minus 1, 2.
Minus 1 comma 2. D?
Minus 2,
2.
2.
Minus 2 comma 2. Next E?
So minus 2, 1.
Minus 2 comma
1.
1. Okay, clear? So this is how exactly we are going to follow by using AC. Yes, absolutely. Now we are following the ICS. Now consider this ICS and tell me. 0 is 0 comma 0. A is also same point. A is also 0 comma 1. Now what will be B value?
Minus 1, 0.
0.
B is minus 1 comma 0. C?
0. 0, 1.
0, 1.
Okay. D? D?
Minus 1, 0.
E?
So 0, minus 1.
F? What is the value of F?
So minus 1,
Minus 1,
0.
minus 1.
So minus 1, 0.
0. Now see the difference. Now which one is easier? Well, coming to these two. Instead of giving values is easier or giving values is easier?
Sir, ICS one is easy.
That
Sir,
is
ACS one is easier because for ICS we have to find first ACS.
See, some operators will consider this as a easier one, whereas some operators will consider this as easier. That is why machine is having both things involved. See, even this in this application, now which application I need to prefer? Whether I need to go for continuous path or do I need to go for point to point? This is a CNC turning operation is there. So this is the raw material. Okay, this is how the raw material will be. Now I want to remove the excess raw material and finally I want to prepare this point. These are the points. By using A and by using C, I have defined these many number of points. Now here, which application I need to perform? I mean on all pages I need to perform. Whether I need to follow CP or whether I need to follow P to P.
So point to point.
Why point to point? Why not continuous?
Sir, because sir, there is lag between means for FE and for AB. We have to we have to stop and perform first AB1, then we have to move to the FE1, and then we have to stop and perform the FE1.
Okay, fine. For every lathe application, we will be using point to point only. Why? Because at each and every point we have to check and we have to define. So how the material will be dispatched. After that only you need to give the material. So if you follow this continuous path, what will be happen? You won't get this 90 degrees angle. So it will be removing the excess material and you will be giving like this. And finally you will be getting this type of path instead of this path. That is what exactly happened in this continuous path in a turning application. If the same application is performed on a milling machine, so you want to do the face milling. So I want to remove the excess material from this face. Now, if which path you need to follow, continuous or a point to point? You want to remove complete excess material only, not considering this path. This is like this. This circle you have to left and you have to remove the excess material. So you have to remove some 2 centimeters. So this is like this. Path will be like this. On the top surface you
Okay.
have to remove 2 centimeters. You have to remove 2 centimeters of excess material. So which one you need
So
to
we
prefer, continuous or
CPC,
point to point?
CPC.
Why CP? See, if continuous path, what will be happen? You have to define first point. Again define second point. Third point. What will be happen at each every point? So a drill will be happened. A holes, cavities will be happened, but not the face milling. For the face milling, continuous movement is needed. So you need to start the operation here, and based upon this, it will be going like this. It will be following the least curve, or it will be following this curvature, and it will be removing like this. In a helical way, it will going to continuously remove the material like this. So even if you go through any milling videos, then it will be like this only. The material will be removed and it will be stopped at this location. So this is how the material will be removed. And there will be excess material that will be left in the corners. So if the material is having this rectangular shape, and definitely there will be a material that will be left in the corner. So even if at all you want to remove that material also, then you need to define the program from outer surface initially. Then this excess material also be removed. This is what the advantage of continuous as well as point to point. So not only in a robotics, even in the CNC machines, even in every application, you will follow this type of things. If it is a application is prescribing continuous movement or continuous way, then you are going to follow continuous. So if there is an precise application is there where the robot movement or the machine movement need to be constrained, then at that application you have to go for the point to point only. Clear? Even the same with the follow with the robot also. So if at all you want to do some pick and place applications, at that application definitely you need to go for a point to point. Why? Because you have to go to some location, and at that location the robot need to be static and it will pick the part. I mean the structural movement of the robot need to be holded, and because of the wrist movement the part will be picked, and again the robot structural movement will be performed. That is what exactly happened in the continuous part, I mean point to point. Whereas in continuous, what will be happen, the structural as well as the wrist, both actions will be simultaneously performed. That is what exactly continuous is. Clear?
सर
Yes.
हम सर एक ही एजम्पशन कर सकते हैं क्या कि आईसीएस के लिए हम मोस्ट ऑफनली पॉइंट टू पॉइंट यूज करेंगे?
Yes.
मतलब सॉरी, उल्टा बोल दिया मैंने कि पॉइंट टू पॉइंट के लिए हम आईसीएस ही यूज करेंगे और कंटिन्यूअस के लिए हम एब्सोल्यूट यूज करेंगे मोस्ट ऑफनली।
Yes, most
हम ये
oftenly
ऐसा
यही यूज होता है। आईसीएस में
ओके
क्या, एसीएस में क्या होता है कि पॉइंट टू पॉइंट फॉर एवरी पॉइंट आपको ये आई मीन अगर आपने पॉइंट टू पॉइंट गया तो इसमें दिक्कत आता है कि आप, मैंने बोला स्टार्टिंग में, अगर ज़्यादा पॉइंट्स है तो उस टाइम पे क्या हो जाएगा, इस जगह जाने के पहले आपको मालूम भी नहीं होता कि एक्स कहाँ है, ऑरिजिन कहाँ है, एंड इट इज़ डिफिकल्ट फॉर यू टू ट्रेस वेयर एग्जैक्टली द प्रीवियस आई मीन द स्टार्टिंग point is sometimes. If it is absolute coordinate system, what will be happen, there is a previous point that is visible for you at in and around location, maybe even it is in somewhat near region. So it is easier for you to pick a part, I mean pick a point from this point, considering this ACS as a one. That is why mostly point to point will be used ACS as a reference. But still, as said, based upon the operator.
ACS
If
or
the
ICS?
ICS, incremental coordinate system. So based upon the operator flexibility, if the operator is completely flexible with this absolute coordinate system only, he is not aware of this ICS, then he will follow even what how much complex is here, but still he will follow the absolute coordinate system only. If someone knows both, then based upon the application usage, as said, so if there is a point-to-point application, then definitely you will try to follow ICSY because it is somewhat easier when compared to the absolute coordinate system in a point-to-point. It's like a vice versa. If it is a continuous point is there at the continuous point, if they are going to follow ICS, then it is a waste of time. At the time they are going to follow this one. Okay. Now some of the technical features of robot. What is this video? Just a second. Yes. Okay, just a second. I will be showing you some features. Just have a look on this video so that you will be having clear idea on what are the capabilities of robotics. Okay. So as you see in the video, so in that there are a lot of things that will be involved. So what are the different applications that can performed by a robot? All the things that I have shown in this video. Now there are some other technical features that are definitely needed for a robotics. First one is a work volume. What is the work volume? We have discussed already this one.
Robotic envelope.
Yes. Again, what is a robotic envelope?
The maximum volume or area covered by the robotic arm.
Yes.
So up to what area it can reach to perform the task.
See, this is a base inside view. If a robot was mounted like this and there are some arms, If this is a small robot, then what is the area it will going to cover? So definitely, if it is a twisting, it is having some theta 1, then only up to this extent the robot is having. That is called as a work volume, which means work capacity, how much area it will cover while doing the operation that can be done by this robot is nothing but work volume or work envelope. Okay. What happened? Okay, that is work volume. Precision of movement, one of the one of the feature of the robot is precision of movement, which is nothing but let us take an example of pick and place application. This is a robot, and the robot need to pick material from conveyor. This is a conveyor from where the material is coming. The robot need to pick a material from this conveyor, and it should supposed to place at this mission. This is a mission, and in the CNC machine this part need to be fixed, I mean placed. This is what need to be happen. If there is a lack of precision, then what will be happen? There is a part like this, it is going come, the robot will pick the part and it will be reaching to this location, it will go into place at this location. After placing here the component like this, then there are some jigs and fixtures in the machine that will hold this part, and simultaneously the operation need to be performed by this CNC machine. Now if there is a lack of precision, then what will be happen? Lack of precision in the movement, then what will be happen?
There will be defected working, means the CNC machine will produce a defected product.
No, see, here we are not talking about a CNC machine. Precision of movement. So the robot need to pick a part and it need to place here. So if there is an error in the movement, or if there is some flaws in the error, then what will be happen to the this one completely? So will the robot able to place the part at the precise location?
No, sir.
That is what exactly precision of movement. If this movement is having some 60 degrees, the robot need to move 60 degrees exactly. If the robot will tend to move 61 degrees, is it acceptable? Similarly with the 59
No,
also,
sir.
if the robot will move 59 degrees, so which is convincible or acceptable to the mission?
No, sir.
No, sir.
Which is no way acceptable. The robot need to follow the 60 degree also. Even 60 degree and 1 minute is also not acceptable. Why? Because there are some jigs and fixtures here. The robot, I mean the part need to be fixed at that precise location. Otherwise what will be happen? The part will be outside. I mean side view. This is the bench wise, and there is a cavity here. In that cavity the part need to be placed like this, then only the part, I mean the operation need to be performed. If because of the 60 degrees the part will be placed here, if it is 61 degree, will the part will be placed in this cavity? It won't follow this cavity. Then what will be
Also,
happen? Again it will be a difficulty. Even though there is a 60 degree and 1 minute of difference is there, still the part will be in a this like this upward downward direction. It will be half in the cavity and half in the vice. It will be like this, so it won't fit. So precision in the movement will also always plays a key role in this one. If at all we are talking about a welding, okay, this is the welding area where two parts will be there, and I need to do welding application here. So I want to do this welding application. This is a 5 mm welding. Okay, the length of the welding is 5 mm. For this 5 mm, 2.5 centimeters here, 2.5 centimeters for this plate. If it was exceeded, I mean here there will be 1 centimeter, here it will be 4 centimeter, is it acceptable? There are two plates like this, and okay, this is plate 1 and this is plate 2. Here there should be a welding. Okay, this welding length should be 5 mm of length. Okay, in that 5 mm of length, 2.5 centimeters on this plate and 2.5 centimeters on this plate was equal distributed, supposed to be distributed. Now if there is a lack of precision in the movement, then because of this, if it is 1 centimeter here and it will be covering 4 centimeter here, will it be acceptable?
no, sir.
In this condition, what will be happen? If at all I have done the welding and I have given the plate to the quality department, now what will be happened? this will going to fail. Why? Because 1 mm of welding will no way hold the part continuously, so it will going to fail because of this one. That is why precision of movement will also plays a key role in the robot. Next one is speed of movement. What is the speed of movement? Why then there is a need of speed in the movement? What is the necessity of speed of the movement for a robot?
सर सपोज इट कि हम जैसे स्प्रे पेंट कर रहे हैं तो
Hmm.
ज्यादा स्पीड से मूव करेंगे तो वो शायद प्रॉपरली पेंट ना हो पाए, और अगर हम जो प्रॉपर स्पीड जो रिक्वायर्ड स्पीड है उससे मूव करेंगे तो वो शायद फिर अच्छा से फिनिश आ पाए उस पे।
Okay. See, based upon the application, as you said, if there is a car application is there, in the car application, so we can do up to 5 kmph. Maximum is 5 kmph. With 5 kmph speed, we can cover this complete automotive body in a 1 minute spray painting. Okay, this is the maximum time. I mean, this is the best time. But I am not maintaining the speed. Here I have given only 1 kmph speed, and I am trying to do the painting for 5 minutes. What will be happen now? Will there be any delay? I mean, any delay in quality, any differentiation in the quality? The quality which I am getting from this one is always equal to the quality which I am getting to this one. Both are same. Here the
Yes, sir, but
speed. Now what will be happen? How the speed will be considered then? In this both condition, this is a 5 kmph and this is 1 kmph. Here I am getting quality 1, here I am getting quality 2. Both are almost same, similar I should say. Now what will be happen if I use this one? Because of this my rate of production will be reduced. Because of this the robot is capable, or the process is capable of performing a 5 kmph speed. But here I am reducing the speed and I am want to maintain it from 1 kmph, and I have doing the same application for 5 minutes of time. Because of what will be happen, there is a lot of bottleneck in the plant. If the robot will be having, if the application will be needed the speed, then definitely you need to do this application. If there is a spot welding application, in the spot welding application, what will be happen if I go for 5 kmph instead of 1 kmph? It was designed for 1 kmph. Now the robot is capable of 5 kmph, so I have given 5 kmph to the spot welding robot. Now what will be happen? This is the plate. Here I need to do the first welding. This is smaller plate. Here there will be second spot. Here there is a third spot, and in between this the robot tend to move with 1 kmph speed. Now I have given some 5 kmph speed. Now what will be happen between these two stations? The robot will be having continuous jerks. Why? Because at this condition the robot will start from 0 and it will anyhow try to reach the 5 kmph. Why? Because we have given the 5 kmph speed to maintain between these two stations. So once it need to reach the 5 kmph, again it instantly it need to stop. Why? Because the distance between these two points will hardly 5 centimeters. So it need to maintain 5 kmph and instantly it need to drop down to 0. So because of which what will be happen, a sudden jerk will be there for a robot. Because of sudden jerk what will be happen, there will be having an errors in the movement, there will be having some losses in electrical losses, there will be having some PLC losses that will be calculated in the robot. That is why speed will always plays a key in the robot. The robot will, all robots will be designed for 5 kmph, but based upon the end application, based upon the application which we are going to perform, based upon the continuous path or a path to point, so based upon all those things the speed will be varied. Next one is weight carrying capacity. What is this one? One important thing for a robot. Like all these things, this is also one of the important thing. Weight carrying capacity.
How, sir, how much the weight can a robot can lift?
Okay, we'll call it as a payload. Okay, so in robotic language we'll call it as a payload. So the robot will classify one based upon this aspect also. So if there is a small robot is there, the end application will be having 2 kgs, so it need to pick 2 kg of load. Then the robot, I need to purchase a robot which is having some 5 kg of weight, maximum per kg. So if at all my application is lifting 50 kg, then at that application I need to go for some 100 kg payload application robot. So that what will be happen, I can go for this application. Now what will be happen if I try to use this 2 kg 2 kg payload robot to pick this weight? Is it possible to do this application?
No,
no,
sir.
sir.
If at all the same, vice versa, if at all there is a 50 kg robot is there, Now with that 50 kg robot, I am doing the 2 kg application. Now what will be happen? Hmm? At this thing, what will be happen?
सर लिफ्ट तो हो जाएगा सर, पर एफिशिएंट यूज नहीं हो पाएगा उसका, कि अगर वो कहीं और पे यूज होना था तो फिर वो कहीं और की बजाय यहाँ यूज करके अपना टाइम एक हिसाब से बर्बाद कर रहा है.
Yes. See, this robot is designed for 50 kg. The robot is doing for heavy applications. But I mean, by using this heavy robot, we are doing a small application which is a 2 kg application. So that what will be happen? The application can be performed, but at the same time, we are not utilizing this thing. So because of robot is having 50 kg payload, the power capacity, the power, the facilities, all the things that will be involved for the robot will always be more. So because of much more involvement of all these things, resources, the end application will be like this. So this is no way useful to the industry. That is why, so we will be considering this as one of the important factor for the robot based upon the end application. On what application we are using robot? We are using for a picking a glass part. So for that glass part, which robot I need to do? So whether I need to go for a bigger robot or smaller robot? If it is a smaller robot, what type of application I need to perform? How much? What type of part I need to pick? So for that, how much load I need to withstand? All those things I need to check based upon this only weight carrying capacity only. Again, it will be depending upon type of drive system. So based upon this thing, this will be defined. So if the robot is 2 kg of payload, then automatically what is the drive that will be needed? So it should be a pneumatic or it should be a electrical one or a motor. Then only this 2 kg robot will be fine. So if the robot payload is 50 kg, at that application, if I use a pneumatic application, pneumatic drive, what will be happen? If at
It will
all,
fail to perform.
the robot won't perform any operation. Why? Because the pressure that is created by this pneumatics is not even considered for this application. So it will definitely fail. So if at all I use a servo motor or stepped motor for this example, what will be happen? If the payload is 50 kg, the part I need to lift is 50 kg. Now I am using a servo motor here. This is a servo motor. Now what will be happen if I try to pick 50 kg of load because with this one? And it's a continuous run. It's not a single application. It should be run for 100 number of repetitions.
So what is servo motor?
Same, just like a DC motor is also a motor, but it is controlled with some feedbacks. So we can control in DC motor what will be happen. So we can't control this movement. So if the motor is defined for 360 rpm, so the motor will rotate at 360 rpm only continuously. So if at all I want to run this motor at some 20 rpm, it is not possible in this one. Whereas in this one it is possible, and we can stop at any location. So if at all I want to run this with 1 rpm, it is possible. At 1 rpm, I can stop at 1 degree, 2 degree, 3 degree, 4 degree, like at any stop, I can hold this one. That is what exactly the main advantage of servo motor. I can stop and I can control this motion. Now, if I use this servo type motor or DC motor here in this one, servo motor for this robot, now what will be happen? Will I able to do this application? If the motor is large, if it is a large motor, maybe it can do this application for one run or two runs, but not for 50, I mean n number 100 number of repetitions, 100 number of turns. Why? Because the motor is also work with the same principle. There will be having some gears involved in it. So because of high edge payload, what will be happen? There will be having a huge load on this meshing gears. Because of this, what will be happen? There will be a continuous wear on these things. So because of where this will also fail. Like this, based upon the end application, we are going to find which drive system I need to adopt. So that will be depending upon the weight carrying capacity. So these are all the primary things that will be needed for a robot. If at all you are going to purchase a robot, if at all the industry is purchasing a robot for some application, then these are the things that they need to consider before purchasing a robot. Like how much envelope it will be. Just a second. Here there is an application, industrial robot application, where the car body need to pick. See, this is the robot. The car body need to pick from this location. This is like some 50 centimeters, not 50, 100 centimeters distance, and it will place at some 100 distance, 100 centimeters. Again it will pick a part from this 100 centimeters, it will place a 100 centimeters. Now this is called as a work volume. The robot can pick part from this one and it will reach this one. And there is a spherical atmosphere also. I mean, it can hold the part and it will rotate in the clockwise direction, anti-clockwise direction in 360-degree circle. So this is called as a work volume. So if at all I'm purchasing a robot, so what would be the work volume? What is the application? Based upon the application, how much work volume I need to prefer. After that, how much precision I am going to need for that one. So after that, what will be the maximum speed of the robot? So if the robot is designed for 20 kmph, so will this speed will be acceptable or not? So whether I need a 20 kmph or a 10 kmph or a 5 kmph, I need for this application, I have to search for that also. Why? Because lifting this chassis and it need to hold this position. So if the robot is designed for 20 kmph, then what will be happen if I maintain the 20 kmph? There will be having a huge jerk, there will be having some losses in that particular application. So that after lifting a heavy part, the robot will tend to move slowly. So it should supposed to move slowly only, at least some moderate speed. Then only we will be capable of doing some precise applications. So 20 speed is always not a matter. So that will also be defined. Weight carrying capacity, if at all I am lifting this component, so how much it is, should, if it is having 10 kg of load, so then what is the robot that is needed for this application? If it is 20 kg of load, then what is the type of robot I need to adapt? Again, if it is a 20 kg of load, that is for my end application, 10 kg, 20 kg. So that application, what type of drive system I need to adapt? I need to go for a pneumatic or hydraulic or some motor based application. Like I need to define, I need to think on all these things before purchasing a robot or before considering a robot. These are the some of the important factors as well as features as well as key aspects of a robot we will be calling as. Okay. Okay.
सर
Yes.
सर ड्राइव सिस्टम को हम इलेक्ट्रोमैग्नेटिक भी बना सकते हैं क्या? मतलब ये 3 कैटेगरी डिफाइंड है कि हम एक इलेक्ट्रोमैग्नेटिक भी यूज कर सकते हैं, जैसे आपने कहा चेसिस लिफ्ट करना है तो हम बेस्ट तो इलेक्ट्रोमैग्नेट रहेगा सर.
But maintaining electromagneticity for an industry is always a difficult task, whereas hydraulic is a easier task for industry. Maintaining hydraulics is easier for industry, whereas to maintain a electromagnetics. That is why industry, if it is an higher application, definitely industry will go for an hydraulic application. All they need is a directly a piston and a cylinder. See, there is a piston here and there is a cylinder, and they will induce this hydraulic oil here. That's it. So even if it is a 50 kg, 100 kg, 200 kg, automatically, instantly, smoothly, the robot will do that application. If it is an electromagneticity, then there will be having lot of limitations. I need to maintain lot of things for me to maintain all these things in a running industry. If it is single application, if it is a 2 robots, 3 robots, okay, that is a fine acceptable one. Then what will be happen if it is having 50 robots or 100 number of robots that will doing the same application? Then it is difficult for me to maintain this electromagneticity. At the same time, if there is an electromagnetic involvement is there, at the same time, there are a lot of other things that also involved at the simultaneously. Now I need to maintain. So these things won't provoke these things. That I need to take care of that also. Those are the lot of limitations for electromagneticity in the running industries. That is why they are not going to use this one. So instead of it, they will be using hydraulic air for higher applications. Okay.
Okay, sir.
Okay, that's it from today's session. Tomorrow I am going to explain you all these important things. If at all, like I said in the previous slide, so if at all you want to purchase a robot, or you will be a general manager in a company and you have gotten a quotation, you want to purchase a robot for an application, then what type of robot you need to purchase, on what basis you are going to define. These are the different areas from which, so you need to select which type of robot will be fixed for which thing application, that you need to search all these things. Okay, tomorrow we will be discussing all these things, like if at all you want to select a robot or if at all you want to purchase a robot, on what basis you will be purchasing, what will be the size, what is the degrees of freedom, how the movement will be classified, how the end effectors will be, how the grippers need to be, all the things we will be discussing in tomorrow's session. Okay, fine.
Okay, sir.
Any doubt so far? Clear as of now?
No, sir.
Okay, still if you are
Yes.
having any doubt, don't worry. Tomorrow again, before starting this, we will try